This is an investigative journey on a key element of design for sustainability. From a near impossible attempt to repair my headphones, to conversations with experts from 8 different disciplines. Join me down a rabbit hole of questions that are too complex to untangle, but too important to ignore. My name's Stu Pullen, and I'm a creative technologist, and I've had the pleasure of working on this Right to Repair blog series for DesignSpark, which is RS Components. It all actually started off when I was looking at my headphones of 6 years of age of use, and they still worked fine other than the battery was basically dead. I wondered why these old school batteries that you used to get in mobile phones couldn't just clip into the place of the headphones and keep them in play for longer. So I set off on a mission to find out. Would I do it? Could I do it? And should I do it? Or would it be a tremendous waste of time? I first stopped the birthplace of many household electronic items. As one does, I've come to Sham Shai Po in Hong Kong to try and get a replacement for one of these, and rather surprisingly, since I was here last, no such place for just random wholesale LiPo batteries, which is a bit of a shame. And it's now something that people end up just buying online. This is my little sort of workshop setup, home away from home whilst in Hong Kong. Currently researching all the batteries that I got from China, ordered via AliExpress. Really interested to see how all this stuff comes out. I've been charging these on various cycles with new batteries. It feels like I'm hitting exactly the same problem time and time again, which is that the PCB that's at the end of the battery, which is the little bit of green in there at the end behind the yellow tape, if you can just see it, that basically, I have a suspicion the firmware on the device is sort of either sending a message looking for a resistance or some identifying characteristic, which when it's not quite getting it, it might be shutting it down. So it does pose an interesting question why I can buy, actually a good example, there is a little remote control toy here. Why is it that I can buy a Duracell battery and put it into an appliance? The performance might be different, but fundamentally they do work and it doesn't do damage to the car. I kind of feel that lithium polymer batteries, all being at 3.7 volts, and of course with various milliamp hour capacities, should all basically work reasonably well with appliances, if like for like is exchanged. It's certainly becoming quite a rabbit hole. I've been reading up a lot about how these things charge, all the sort of quirky characteristics of how they sort of switch on and switch off during that discharge or recharge cycle, how that affects the health. Basically at the minute, it's a lot of information and it's overwhelming. Back on home turf, the battery tests continue with little success. Look at all these lovely batteries that I've been testing, all of which don't work. So the conclusion of that is that either basically all of these have an unusual characteristic which this thing has been wired to look for that characteristic and basically reject. It could of course just simply be that this is 6 years old, maybe some sweat, rain, a knock, something has caused this internally to have a problem as well. So it could be that the only way to sort of really validate that is essentially buying another pair, and so that's basically what I've managed to do. I found a working pair secondhand. So what I'm hoping to do is basically take the new battery that is in good condition and I put it in here. What I'll essentially find out is if it was the battery or whether this thing genuinely has some other problem inside it just because of its age. What I've done now is taken the old headphones, you can see from the sort of ratty top, and I've put in the new battery from the second hand, but essentially it's strobing, which means it thinks it's fully charged. And then it's also sort of showing a little unusual single dot, which claims that it's also empty. So it's basically gone into a state of confusion. The only sort of rational conclusion is that whatever, this has been knocked, got some ingress, something's corroded, a small component has failed, and that might explain why basically none of the new batteries are charging. Especially if you consider I'm putting essentially a legit battery in it that definitely works. So yeah, rather frustrating, but at the same time, as an engineer, good to finally close off one of the avenues. If repairing the headphones wasn't to be, they would surely go to a recycling facility, given they shouldn't just be dumped in the bin. I visited one such place to see for myself. I'm here today at Sweet Kusakoski, which is one of the UK's largest recycling plants of electrical wastes from consumer goods. And this is just one load of 10 which will be coming in today, and it's just absolutely extraordinary to see the huge amount of appliances that I'm familiar with, and even a couple, weirdly, that I designed myself whilst at Dyson. This is extraordinary to think that the massive pile behind me represents about 1/10 of what's going to arrive today. Crazier still is that this is 30% of what is actually taken from UK households. The other 70% ends up in landfill, incineration, or frankly, God knows where. Seeing the colossal amount of household items that have ended up here, especially ones that still have some life in them, really hit home about the impact of electronic appliances not being easily repaired. Time for a rethink so my headphones don't end up in the same way. So, in desperation and curiosity, I've decided to sort of get these optics out just basically to help me have a look at the extremely fiddly little rat's nest that is the wiring here. You see what I mean though? Total chaos. I mean, look at that bit on the like the bottom left. That's just like flapping around. Outrageous. So I have made a little sort of intervention charge circuit here, which I've done a test just switching it on, and it basically powers up all fine. And as you can see, that everything's all sort of quite loose at the minute. But I'm just testing the general circuitry of basically sort of, if you like, a sort of circuitry heart bypass of the battery basically now being part of the TP4056 circuit. Due to a lack of space inside the headphones, the circuit board would need to sit outside. But how to find a solution that was tidy and waterproof? To the 3D printer. Free charging. There we go. Can you see the red light? Yes. So really pleased to give this a new lease of life. And, you know, bit of a pity that something on the hardware failed, but it's been a great vehicle to really understand the whole journey of batteries, technology, and of course the right to repair angle. So this certainly has been, as I'm calling it, a fight to repair, but a very educational and useful one, and hope you found the same. Thanks again.